Hello students, my name is Kritika Kungat and I am going to teach you today data transfer instructions of microcontroller 8051. So we'll start with what is data transfer instructions. As the name suggests, data transfer, here we are performing the operation of transferring the data from one location to another location. So the location where we are transferring the data is the destination location, and from where the data have been transferred is the source location. So data transfer instructions are responsible for transferring data between various memory storing elements like register, RAM and ROM. The execution time of these instructions varies based on how complex an operation they have to perform. So now we head with types of data instructions. We have three types of data instruction. Over here is move instructions, push and pop instructions, and exchange instructions. We'll start with move instruction first. Move instruction, basically when we want to move or copy the content of source to destination location, we use the move instruction. Okay, so over here we can use any of the special function register, accumulator, or any register as source or destination location. The move instructions has two operand, here the source and the destination. So the second operand is the source, whereas the first operand is the destination. This instruction uses various addressing mode to move the data in RAM space of the microcontroller. Now, first move instruction is move the content of register Rn to accumulator. Now, here Rn, we have used Rn, N is 0 to 7. In 3 register banks from 0, 1, 2, 3, 4, we have 8 registers in each register bank, and all the 8 registers are 0 to 7. So, in the first instruction, we are using the register R2 of the register bank. So we are moving the content of R2 register to accumulator A. So first instruction is move A, R2, and second instruction is move A, R7. Okay, here we are moving the content of R2 register and R7 register to accumulator. Second move instruction is move the content of accumulator A to register Rn. Here we are moving the content of register into accumulator. We have used two registers over here, R4 and R3 for examples. We are moving the content of accumulator to R4 in the first instruction, and we are moving the content of accumulator into R3 register in the second example. Now, move an immediate 8-bit data to accumulator or to register Rn or to memory location, and we can use it as direct addressing or indirect addressing both. Now, firstly I want to tell you the difference between immediate 8-bit data and a memory location. Okay, we start with the first instruction, move A, hash 45H. Over here we have used the hash sign with the 45. So here when we use hash with any instruction over here, this is the immediate 8-bit data. Always keep in mind that if we use hash with it, it will be a 8-bit data, and if we do not use hash, it will be a memory location. If the instruction is like this, move A, 45H, we say that we are moving the content of memory location 45H to accumulator, but we are using over here hash 45H, so we say we are moving the content of immediate 8-bit data 45H to accumulator. The second instruction is move R6, hash 56H. We are moving immediate 8-bit data 56H into R6 register. Third is we are moving move 30H, hash 45H. 44H, sorry. You can see over here the 44H is the 8-bit data and 30H is the memory location. We have taken 3 examples. In the first we are using accumulators, in second we are using R6 register, and the third we are using memory location. We are moving the content into accumulator, register and memory location respectively. So here 30H is the memory location. So we say over here we are moving the content of the immediate data 8-bit data 44H into memory location 30H. Now next we are using the indirect addressing. In indirect addressing, in the first example, we are using asterisk sign, @ sign with R0, because when we use indirect addressing, we use this asterisk sign because we are taking over here the location of the in R0, the address is placed in which we want to move the content. Okay, so move asterisk R0, comma hash 0 E8H. We are moving the content of this 8-bit data into the memory location of R0. Now move dptr comma hash 0F5A2H. We are not using over here the 8-bit data. We are using 16-bit data for dptr because dptr is 16-bit register. So we are using 16-bit data. Again, in the next instruction, we are using 16-bit data hash 5467H. We are using 16-bit data which we are moving to dptr. So next move instruction is move the content of memory location to accumulator or accumulator to memory location. So we can use any of the addressing mode, direct or indirect. First we start with direct addressing. Move A, 65H. Here 65H is the memory location. We are moving the content of memory location 65H into accumulator. In the next example, we are moving the content of 56H memory location to register R6. And next we'll start with the indirect addressing. In indirect addressing, we are moving the content of memory location. Here asterisk sign is used for the memory location. @R0. @R0 means R0 is the memory location where the address of that location is placed, where we want to move the content of accumulator. So the asterisk sign is used for the memory location over here. Move A, comma asterisk R0, asterisk or @ we can use any word for it. So we are moving the content of memory location R0 to accumulator, and next is we are moving the content of accumulator to memory location R1. Okay, so in both the examples we have used asterisk sign for the memory location over here because we are using the indirect addressing for this examples. So next we have move the content of register Rn to memory location or a memory location to Rn. We use this for only direct addressing mode. Now the example is move R3, 65H. Here 65H is the memory location. We are moving the content of memory location 65H into R3 register. Next is move 45H, R2. We are moving the content of R2 register into 45H memory location. Now next is move the content of one memory location to another memory location. Direct or indirect, we can use any of the addressing over here, direct or indirect. First example is for the direct addressing mode is move 47H, 65H. We can see over here 47H is a memory location and 65H is also a memory location. We are moving the content of 65H memory location to 47H memory location. Now next is we are using the indirect addressing mode. We are moving the content of 35 R0 register memory location to 35H memory location. So this is how we move the content of one memory location to another memory location. Next we are move ahead with it. Move the content of an external memory to accumulator or accumulator to external memory. So here we have changed the mnemonics. We have used move X, except we were using move instruction, move mnemonic earlier. We are using over here move X mnemonic because we use move X mnemonic whenever we want to use it for external memory. X denotes the external memory. Okay, so first instruction is move X A, @ R1. We always use indirect addressing for external memory because in indirect addressing we always talk about memory location. So whenever we use this instruction move x, we use indirect addressing. So we have used indirect addressing in all the examples over here. First example is move x a comma at strict r1. We are moving the content of memory location r1 to accumulator. Move x a comma asterisk dptr, we are moving the content of dptr to a. Move x asterisk r0 comma a, we are moving the content of accumulator to memory location r0. And move x at asterisk dptr comma a. These are some of the examples when we use the external memory. Next is move the content of accumulator to program memory. So for this we use the mnemonic move C for it. Here you can see in the examples we have used the mnemonic move C. So over here the first example is move CA comma asterisk A plus PC. PC over here is the program counter. PC is denoted for program counter. We are moving the content of program memory where the program asterisk A plus PC is the program memory. Okay, here asterisk A is the offset address and complete A plus PC at the rate A plus PC becomes the address of a memory location in the program memory. So the second instruction is move C A comma asterisk A plus dptr. Here dptr is data pointer again. Here asterisk A is the offset address and complete asterisk A plus dptr becomes the address of a memory location in the program memory. So this was all about the data transfer instructions. In the next video, we're gonna start with push pop instructions and exchange instructions of data transfer instructions of 8051. Thank you.